All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you're going to do remove, replace, reduce. So x squared minus 10x plus 24. Then you're going to have 3x minus 6, 3x minus 4. Then the first one will reduce to be x minus 2 and 3x minus 4. Okay, for the math knowledge question, you want to distribute, so you'll have 8 plus 20x plus 9 minus 2x. 20x minus 2x is 18x. 8 plus 9 is 17. So C would be your answer. We are looking at lesson 33 today, factors of polynomial functions and graphs of polynomial functions. This actually should mostly be review from pre-calculus, so hopefully this will jog your memory and it won't be all a new concept. So the degree of your polynomial is the value of the greatest exponent. That's how you're going to look at your polynomials. You'll find the largest exponent, and that's the one that we're going to be concerned with. The behavior of your polynomial for large absolute values of x can be determined by looking at the exponent of your highest degree term and the sign of the coefficient of that term. So all of the other stuff is going to be irrelevant when you're looking for the behavior of the graph. You only want to look at your highest degree term. So the function x squared plus 4 is an irreducible quadratic because it cannot be factored. X squared plus 4 is irreducible. You cannot factor it. So that function will never equal 0, and so they never cause your polynomial to equal 0. So when you have an irreducible quadratic factor, you're just going to mark it out and ignore it. You're not going to deal with them. Your graph of your polynomial is going to cross the x-axis when a real linear factor occurs an odd number of times, and it's going to touch but not cross it when it occurs an even number of times. So we, back several lessons ago, several weeks ago, did graphs where we had dots, and then we went like this, and that was because it would be like x minus 3, x plus 1, x minus 4, where this is -1, 3, and 4. However, if this x plus 1 had a squared on it, then it would actually touch it and bounce away. So if it occurs an odd number of times, so x minus 3 is to the first, that's an odd number, it's going to cross the x-axis. Same thing with the x minus 4, it's going to cross the x-axis. But if it occurs an even number of times, like this 2, then it's going to touch it and bounce away. Okay, so you need to remember that. For this one, where does it touch the x-axis and where does it cross the x-axis? So first off, we want to look, this is going to give us a -4. This one is going to give us a -2. What about this x squared plus 3? That's irreducible, so we mark it out. We don't use it. This one is going to be a +5, and this one is going to be a +7. So it's going to cross the x-axis where it is an odd exponent. So where are our odd exponents? Here and here. So we're going to have it crossing at -4 and 5. And where is it going to touch? That's where it's going to have an even exponent. Okay, so where is it going to touch it? Where it's an even, which is -2 and 7. Okay, so y'all see how that works? Now looking at this one, which one most resembles this graph, this equation? So our numbers that we're going to be concerned with are 1 and -2. So this one talks about -1 and 2. So we're not going to use that. This one talks about 1 and -2, okay? This one is -1 and 2. We don't want that one. And this one is -2 and 1. So it's either B or D. Those are both squares. So what's going to happen at -2 and at 1? Is it going to bounce or is it going to touch? When they are squared, I'm sorry, is it going to touch or bounce, or is it going to go through? Since they're squared, it's going to touch or it's going to bounce at both of them. So D would be the graph that we would use. This equation would be if the 1 was to an odd number. So if this was a 1 or a 3, that would be the graph you would pick. Okay. Now we're going to look at turning point theorem. It tells us that your polynomial function is always going to have fewer turning points than the degree of the polynomial. So let's start with a parabola, because we're pretty familiar with parabolas. Y equals x squared. The degree is a 2. So what is a number that is less than 2? 1. So it's going to have 1 turning point. And if you think about a parabola, it turns once, no matter which direction you're going. Okay, what about a line? The degree is 1, so it will have 0 turning points, because the number less than 1 is 0. And it's straight, it never turns. Same thing with x to the 4th, x to the 5th. They're always going to have fewer turning points than the degree of the polynomial. Alright, so which one is most likely to produce this graph? So if you look, we have 1 turning point here, 1 here, 1 here, and 1 here. So we have 4. And if you notice, we've got an x to the 7th, and negative x to the 6th, and a negative x to the 5th. So all of those are more than 4, so we can't eliminate any of those. So what we need to look at is the endpoints. As it goes to the left, it's approaching positive infinity, and as it goes to the right, it's going down. So if you remember this from pre-cal, x squared, when it's positive, is going to look like this. X to the 3rd, when it's positive, is going to look like this. X to the 4th, when it's positive, is going to look like this. X to the 5th, when it's positive, is going to look like that. X to the 6th, when it's positive, it's going to do that. And then x to the 7th is going to go back to something like that. And then whenever they are negatives, I'm just going to I'll pull it down here and then I'll flip it. Okay, when they're negatives, I know you can't tell what these are now, but this is going to be negative x squared. This is going to be negative x cubed, negative x to the 4th, negative x to the 5th, negative x to the 6th, negative x to the 7th. So I stopped at 7 because that's where we go up to. So if you look at the even powers, you see how both of them are going up here? And both of the endpoints are going up. Both of them are going up. The even powers, when they're positive, they're going to both be going up. And when they're negative, they're both going to be going down. Okay? So if you look here, we know it's not going to be an even power, so it's not g of x, because they're pointed in opposite directions. Now, I didn't draw x to the 1st power. That's just a line. If it's positive x, it's going to be going up like this. And so, same thing with x to the 5th and x to the 7th. If you have a positive, then it's going to be increasing. But if you notice, our endpoints are going down. So it's not positive x to the 7th. So that leaves it as a negative x to the 5th. And if you look, your negative odd power are going down. Okay? So this one would most likely be h of x. Alright, so let's look at some more on what I was just going over. If your lead coefficient is positive and it has an odd power, it looks like a line from going endpoint to endpoint. You're going up like that. If it's negative and has an odd power, then it's still going to look like a line that has a negative slope going down. Okay? If your lead coefficient is positive and has an even power, it's going to look like your parabola, and they're both going to be going up. And if it's negative and has an even power, they're both going to be pointing down, still like a negative parabola. So those are the basic rules that you need to learn for graphs of polynomial functions. So for the average value of all the roots given, it's by this formula, and it's read x bar, negative b over NA. N is the degree, whatever your highest exponent is. A is your lead coefficient, and then B is your second coefficient. So whatever is the next highest power, that coefficient is going to be your B. So for a quadratic, it's the value of your vertex. For a cubic, it's the value of your inflection point, which we'll get into inflection points more later, but I'm going to graph. This is going to be your inflection point, where it changes from going down to starting to go back up. This right here. And then for a quartic, x bar just gives you an idea of the center of the graph. So some people use x bar just so that you know where to start, kind of in the center of your graph. So that's what I was just telling you about the cubic and for the quartics. Alright, so we want to sketch this one. So this is a cubic, and so we just need to do a rough sketch of it. We don't have to do like a super great sketch. And so we know if it's a negative cubic, it's going to look like a negative line. So it's going to be going down like that. So we're going to graph. And we're just going to plug in some numbers. So let's plug in 0. 0, 0, 0 would be 3. We get that number there. Let's plug in 1. If we plugged in 1, we'd get negative 1 plus 3 minus 2 plus 3. So that would be 3. Let's plug in 2. If we plug in 2, that would be negative 8. 2 squared is 4 times 3 would be 12. Minus 4 plus 3. So that would be 3 again. Which isn't making much sense probably to some of you, but we're just going to make this little sketch here. Here's what you do. Here's your graph. It just has to have 2 humps, start at the top and fall downward. So there's your graph. And that's really all we need to know about it. So hopefully that's not terribly difficult with your polynomial functions. Your homework tonight is 1 through 25, so make sure you do those so that we can go over any questions you have tomorrow.